Okay, so today we're going to look at geometric sequences. This is section 4.2, and just like in the past we had a sequence before, which is an arithmetic sequence. Here's a sequence. So the first thing that you probably want to do is you want to lay this into a table to kind of help us find what rules are and all that kind of stuff. And we're going to look at some characteristics of this type of sequence. So if I lay this into a table, n being the term number that it's in, a sub n being the value, which is what we see right here, I can see that the first term is a 1, the second term is a 2, the third term is 4, and then the fourth is 8, the fifth is 16, and this can actually continue on out. Okay? So, in an arithmetic, we compare it this way, and we would add the same number each time. But we can see clearly here that adding the same number is not going to work, because this is a +1, then that's a +2, then that's a +4, and so forth. So this is what the other sequence looks like. So unlike the other one, arithmetic sequence, the geometric sequence is a multiplier. So this one is times 2, times 2, times 2, and so forth, and so on. So we are repeating the same multiplication each time. So this number that I'm multiplying to each time can be found mathematically, because it's not always going to be a nice number. Sometimes it can be very difficult to see what the number is. So you want to be able to find it, and you find it by taking two consecutive terms and dividing them. The right one divided by the left one. So the first one would be 2 divided by 1. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. And so this number, which is the same number each time, is what's called the common ratio. The common ratio, and they use the value R for that. So R is the common ratio. It is found by taking two consecutive terms in your geometric sequence and dividing it. Okay? Any two consecutive terms in a sequence divided to produce the same number, then that number is called the common ratio. If a sequence has a common ratio, so in this case, R is equal to 2, then this is called a geometric sequence. Geometric sequences have a common ratio. And so what we want to look at today is we want to look at in the geometric sequence to determine whether or not we actually have one. So by looking for see if it has a common ratio. And then we want to find our two rule types, the explicit rule and the recursive rule. And then we want to be able to graph it and see what these things look like. So the graphing is fairly simple. You just need to simply graph your table that you see right here. And remember, from arithmetic, you're only going to graph dots. You're not going to connect the dots in any way. I'm not going to get all these in there because I didn't make it big enough. And I'm going to go this one by 2. But 1 goes to 1, 2 goes to 2, 3 goes to 4, 4 goes to 8. And then 5 would go to 16, which would be somewhere right about here. And so you can see this little curve action of the dots. This is what a geometric sequence looks like. This type right here. We talked about the exponential function. This is what it looks like. It has a little curvature like this. And we'll explore that function in more detail graphically a little bit later. So how do I find the explicit and the recursive rules? So how to find the explicit rule? So that's what we want to look at right now. What process am I going to find? So the first thing you want to do is find your common ratio. Find a common ratio, R. Okay, so you want to find that. Once you have that, okay, you're going to pick a point from the sequence. So the first way I'm going to show you this, I'm going to show you by picking the first number in the sequence, which is this one, the first term in the sequence. The first term in the sequence is 1. So that point right there. So using that point, so using the first term in the sequence, then I can find the explicit rule because I need the first number in the sequence. And I'm going to times that by the common ratio. And then up here will be n minus 1. And you'll notice some similarities from the arithmetic sequence, which is basically this. I need the first term, and then there's always an n minus 1, meaning that this answer came from the first term. So once I understand that concept, then I can use using any term in the sequence. Now, if you have the first term, use the first one. It makes it a lot cleaner. But I can use any term in a sequence. I'm going to use the a sub k. If I use a sub k term, then it's the k, it's k in the sequence. And so then this rule becomes a sub k, whatever term that is, r to the n minus k. So keep that in mind as you do that. This is the one of the preferred ones to use. And then this one right here is any one in the sequence. So that's how I would do the explicit rule. For the recursive rule, again, you want to find the common ratio. Okay? And then you need to find or identify a sub 1, the first term. And then once you have that, then you can write your rule. You need to have a two-part rule. A sub 1 equals, and then this is the first number in the sequence. Okay, so that's what you're going to put right here. And then you can write the pattern rule. A sub n is the common ratio times the previous answer. You get the next number in the sequence, take the previous answer, and times it by the common ratio. And so that together is your recursive rule. Okay? So those are the three things we're going to be looking at. So we can come up here to the problem that I previously had up here, and we can write the explicit rule up here for this, since I have the common ratio and I have the first term. Then I can write the name of the sequence, which is 1, which we don't really need to write. The common ratio is 2, and then it'd be n minus 1. So that would be the explicit rule for that. That's right there. And the recursive rule is a sub 1 is 1, because that's the first number in the sequence. And then a sub n is the first number in the sequence. And I'm sorry, it'd be the common ratio, which is 2, and then a sub n minus 1. So you need this because it tells you where to start. I can't have a number here until I have the first number. So the next number in the sequence is going to be the previous answer, which is that one. 1 times 2, or 2, so the next number is 2. And then from then on, it's just 2 times the previous answer. So that's how you do those. This is how you would graph. You want to make it go up, not just so you see this big time kind of swooping thing right here. So usually about 5 points, 4 or 5 points will do that for you. Depends on how steep it gets. You want to make sure you see the very steep action here at the very end, okay? And make sure you label your axes and stuff like that. So other than a couple more examples I'm going to show you real quick, that's geometric sequence, how to find the rules and such. So here's a couple more examples. And let's start with 81, 27, 9, 3, 1, and so forth. So we put it into a table. The first term is 81, third, fourth, fifth, 27, 9, 3, 1. So what is the common ratio? So again, if you can't see it this way, just take 2 consecutive numbers, 27 over 81, work that out, and you get 1/3. Take 9 divided by 27, You still get 1/3, so you're going to confirm that you indeed get the common ratio 1/3. And so I know that R is indeed 1/3. And once I know the common ratio, writing it into explicit form is fairly simple. A sub n equals the first number in the sequence, the common ratio, and then n minus 1. So there is the rule for this table. To write the recursive rule, I need the first number in the sequence. And then a sub n is the common ratio times the previous answer. And that would be the recursive rule for this table. I'll do one more for you. And let's do one that kind of changes signs here. See what happens. So this one's alternating. So what is the common ratio going to be? 8 divided by -4, -2. -16 divided by 8 is still -2. So we can see that our common ratio is going to be -2 this time. And that's okay. Our generic recursive rule is the first number in the sequence. So -4 times the common ratio to the n minus 1. And it's that simple. A sub 1 is -4. A sub n is the common ratio and the previous answer. And there you go. That's the geometric sequence. And we'll talk more